Okay, a few more examples. So y equals secant inverse of e to the 3x power. I'm going to pull that. Actually, that's kind of big. Pull it over here. We're going to be working with our derivative of secant inverse here. So we'll work with this formula. But before that, let's go ahead and work on our u. So u is going to be what? E to the 3x. Good. And what's the derivative of u? I'm going to put du. U prime, I mean. What's the derivative of u? Remember, it's e to the 3x times the derivative of that. So e to the 3x times the derivative of that exponent, which would just be 3. And I could simplify that if I wanted to just 3e to the 3x. Now you're familiar enough with this, you can probably skip this step, but whatever you're most comfortable with. Now once we have our u and our u prime, we're able to come over here to our formula, and we'll have y prime is equal to our u, which u prime, 3e to the 3x over absolute value of u times the square root of, what's that, u squared, so let's put u in parentheses, u squared minus 1. Alright, let's take a step to simplify. I'm going to leave my numerator alone. This e to the 3x, can't simplify that anymore, but we can simplify under here. What would this be? What's e to the 3x squared? E to the 6x, and then I just have minus 1. Now, what do you think we could do here? What about this e to the 3x? It's a positive one because it's absolute value. And what about this e to the 3x? Yeah, it looks like we can cancel an e to the 3x out of each, and this would simplify to just 3 over square root e to the 6x minus 1. Okay, one more. This is our last trig function to work with, and we've done one of each. So y equals cosecant inverse square root of x. I'll be pulling the formula while you work on your u and u prime. Okay, so here's the formula we're going to be using, and u was the square root of x, or x to the 1/2. U prime, we actually did this one a minute ago, so if we just use the same one simplified, it's 1/2 x to the negative 1/2, and that simplifies to 1 over 2 square root of x. Right here. Okay. Alright, so now let's plug that into our cosecant. So we're working with this top formula. So the derivative, so I'm going to say y prime is equal to a negative, and then we have our u prime, so 2 square root of x. And then in the denominator, we have the absolute value of the square root of x times the square root of the square root of x squared minus 1. I'm just going to move this over here for a moment. Alright, so now we're just simplifying. So y prime is equal to negative 1. Let's see if there's something in the denominator we can simplify. Not really anything here, so I'm going to leave that alone for the moment. But what about this guy? The square of a square root is just going to be our x. And then now if we wanted to do the reciprocal of the denominator, it would just be, if I multiply by the reciprocal, it would be 1 over this term. Whatever you do the denominator, do to the numerator as well, so that we can simplify. Okay, and then of course everything down here would just cancel, and we would be left with, let me bring it down. y prime is equal to, up here, a -1 times a +1 is just a 1. And then we would have a, what's the square root of x times the square root of x? Just x, so good, that would give me a 2 that I carry down, and then that simplified to an x, and then of course I have that x minus 1 that's under the square root. So, and it is absolutely a negative from -1 times a +1. Okay, so on this next page, let me delete this out the way. On this next page, I'm going to give you some practice problems and then the examples, some practice problems and then the answers to these so that you can just try them on your own time. Okay, so here's one more of each type. You can work on these. So I'll pause this and I'll write them down, and then the next little snapshot, I'm just going to put the solutions up there. Okay, so I alternated colors just so we wouldn't, they kind of run together a little bit. So this is for the first example, second, third, fourth, fifth, and sixth. So those are solutions you can check yourself with.